cleaned it when Okay, we have done graphs of quadratics in Algebra 2. You did them in Algebra 1. We know that the graph of the quadratic makes a parabola. There are two different forms that we will see our functions written in. We know, they use a y or an f of x here, f of x. We know that it's in standard form when it's in ax squared plus bx plus c. The good thing about graphs of quadratics is you can graph them in your calculator. Then you can go to your table and get points. The only thing that you're going to be required to know how to do that your calculator doesn't tell you is how to find the vertex. So when you're in standard form, that's what we got here. Do I need to write that? Standard form. When you're in standard form, to start finding the vertex, the x-coordinate of your vertex is going to be the opposite of b over 2a. Okay, so that'll be the x-coordinate of your vertex. And you know a vertex is an ordered pair, x comma y. So then what would you do to find the y? There's no formula for it. What would you do if you get the x?
Plug it in.
Right, take it back up here and plug it in and find the y. Good job on that, Austin. Now that is the x-coordinate of the vertex. And that is also the axis of symmetry. Because we know that a parabola, if we look, a parabola does have symmetry. You can fold it straight down the middle. So that's also the axis of symmetry, the x-coordinate of the vertex. Okay, so that's what you've got to know for standard form. Alright? So there's some people writing, I'll show you what vertex form. Vertex form tells you the vertex. That's what's called vertex form. We like it. Alright. Everybody alright on that page?
Yes, sir.
Vertex form, I can go back if I lost you. Vertex form is f of x is equal to x minus h squared plus k. The vertex would be hk. That would be the vertex. Now, what you've got to notice on that is x minus h, so the h is always the opposite sign. Okay, so if it said negative 3, it would be a 3. Alright, it's always opposite sign on the h. The k is what it is. Okay, it does what it does. So if that's the vertex, the axis of symmetry would be whatever your h is. Right?
Correct.
Axis of symmetry. Okay, I'm just going to give us some and we'll jump in and see how it goes. Does that sound like a plan? Great.
That's right.
Wrong. But good try. Everybody good on that page? Alright, we've got f of x is equal to negative 3x squared. Right now all I want to know is what's the vertex. Alright, so this is an easy one, but it tricks people because you don't have a whole lot of information. First off, what form would that be in? I gave you a standard form and a vertex form. Be in standard form. Standard form, we do the opposite of b over 2a. Okay, this is when this one becomes a no-brainer because what's your b? 0. So 0 divided by anything is 0. So I know the vertex has got to be at 0 something. Now even better, since there's no b and c here, when I plug that 0 in, what do I get?
0.
So there's your vertex.
Oh, because we're plugging in 0.
Because your b and your c are 0.
It just took time.
Which direction, I haven't told you this yet, let's see how much you remember from previous things. Which direction does this parabola open?
Down.
Good, I heard several people say down, very good. The a is a negative 3, so that means it's going to open down. So it would be something looks like that. Okay?
Was that a stretch or a compression?
It would be, see, if it's bigger than
Stretch,
1, no, it's backwards. If it's bigger than 1, it would be a compression. It gets skinny. When it's a fraction on the A, it gets fat.
Those confuse me.
Yeah, because it's opposite in my brain. You think a big number would stretch it, but it doesn't. All right,
We're gonna learn that stuff?
a little bit.
How's he know? I'm just smart.
Remember stuff from previous classes.
We had trig last
You don't do
I
a lot
do
of
that.
you don't do a lot of parabolas and trig.
year. We had no
We
junk
did
that
that
I
in
don't
algebra
even
too.
know. Well, that was secret, but that was a long time ago. And I was in the kid group.
I'm in here.
They were playing hands up.
That's in Vertex Form.
All right, Austin says this is vertex form. I want to know what's the vertex. So you would say 5, 6. There's your vertex. What's the axis of symmetry? X equals what? 5. Good. Okay. So you could get a good idea without even graphing it of just what that would look like. If it's a vertex at 5, 6, going to go over 5 and up 6. Its axis of symmetry is going to be through that line. What does this open up or down from there? Down, because it's got a negative out in front of it. So it would be looking something similar to that. Now, how would I get some specific points? And there's 2 ways that I know of.
You plug in.
That's good. I can plug that in my calculator and go to the table and look at it. Or what Blake was really meaning is what I would do. Like an input-output table, pick an X and plug it in and see what your Y is.
Yeah, just random numbers.
Yep.
Yeah. Like that.
Okay, everybody all right? Okay. All right. This one, I'm going to do 2 more. 1 more in standard and 1 more in vertex. Well, we've done this since Algebra 1, basically.
I love this class.
I'm glad, Blake.
I love you, Coach Ross.
Oh, I'll still love you too. So warm and fuzzy.
Just small for me.
So I know it's like
A good one in standard form. I don't see a good one in standard.
Give me that.
Okay, this is in standard form. I've got negative 2x squared minus 3. I want us to find the vertex. I want us to find the axis of symmetry. I want us to give the domain and the range. 2 new ones I just added there.
I ain't never learned that stuff. That's
You're
hard.
fixing to. And I want to see what the graph looks like.
Vertex, 0, negative. Only 0, negative 3.
Good.
Axis of symmetry, 0.
Good. Alright, how did Blake know that? That's all correct. We're in standard form, so what did you have to use to find your x and your axis of symmetry?
The X did negative B over 2A.
Okay, we were good. We were looking at negative b over 2a, and what was your b?
0.
0. Because you had ax squared, your a is negative 2. You don't have an x, so your b is 0, and your c is negative 3. So when you do 0 divided by anything, you get 0. Okay?
Right.
Now when we plug that back in, 0 squared times negative 2 is 0. You just had the negative 3 left. Okay? Good on that? Then your x of your vertex is always your axis of symmetry. Good on that? Alright. Domain and range on parabolas are simple because they're the same for almost everything. All that changes on it is the range when it's up and down or the domain when it's sideways. We're going to look at sideways parabolas next week. We're not there yet today. This, since my a is negative, it's going to be going down from 0, negative 3. Now I'm going to make you get a little bit more specific than this in a second. But just to tell the domain and the range, I know it's going to look like that. give a general appearance of that. So domain is x's.
X is equal to all real numbers.
Good. So this thing is going to keep getting wider and wider on the left, and it's going to keep getting wider and wider on the right. So you can say it the way Blake just said, all real numbers. This book that I use for this class seems to do the negative infinity to infinity a lot, but I'll take either one of those. So all real numbers or negative infinity to infinity. And for a normal parabola, an upside down one or a U, that's going to be your domain every time. The only time a parabola will have a different domain is when we look at the ones that open sideways, and that's not till next week. So every time you've got a parabola that looks like this one or an upright one, your domain will be infinity, negative infinity, or all real numbers. Okay, the range, okay, you look at the highest point it hits, and that's your vertex, -3. So I would say this range, it goes down forever, right?
Right.
So there's your negative infinity, and then it stops at what Austin said, 3. Now, can it, -3, can it hit -3?
Yeah.
So what do I got to put on that?
Put a bracket.
Bracket, good job. Alright, either pick some random numbers like the guy said and get me a couple points, or go to y equals on your calculator and plug that in and go to your table and get me a couple of points. Let's get our graph to be a little bit more precise. You remember how to graph that? Hit y equals, type it in. I know I've got 0, -3 already.
1, -5.
Okay.
2, -11.
2, -11. Now let me show you. Okay, you're good. You're good. Let me show you a shortcut on this when you have to graph them by hand. There's your vertex. Okay, I already found that. Now, if I could just find one other point, I would have everything I need.
You can get the other one on the other side.
Good. That's what I like to do too. So
Negative
I would
2,
go over
negative
1 and down 5. Okay, so if that point is there, and this vertex has my axis of symmetry, then if there's a point on this side of it, it's got to be equidistant on the other side.
Right.
So I just do some simple counting, and I say, well, that point is 1 away from the axis of symmetry, so I go 1 away on the other side.
Boom. There you have it.
Pretty much what I drew up there.
There's a wrap.
We didn't do a vertex. You got to do a vertex. A vertex form. Then it will be.
Already? I like Fridays.
Whew. I was struggling today. It's been a long week. Has this not been the longest week ever? Last night when I was trying to fall asleep, I was thinking, well, tomorrow's Saturday. I got to go get some more chicken feed. I got to do blah, blah, blah. And then I was like, tomorrow's not Saturday, you doofus.
Not
Do you
me.
buy chicken feet?
Yeah, I feed my chickens.
Oh, I thought you said feet, not
No.
feed.
Oh, no, I don't buy chicken feet. Do people buy chicken feet?
If you got a snake, maybe feed them some chicken feet. You rather feed them mice.
I had a snake, but it, no.
I don't want to see.
Dead.
I say maybe like, bring me a rat. Put it in my car. Alright, we got f of x. F of x is equal to x plus 2 squared minus 1. You're going to tell the vertex again, same stuff, the axis of symmetry, the domain, the range, and you're going to graph it.
First, we're going to have negative 2, negative
Alright,
2.
now
Keep going.
on the -2, -1, the only thing that people will miss on that is they'll forget to make their h the opposite. Like, remember that it's a positive 2, so he made a -2. Everybody good on the vertex?
Yes.
All right.
Michael's
You can come in. I'm going to go back. We're good.
Yeah.
They're getting it, so you're getting it. They're bringing it.
Last Friday.
I I just wanted to, yeah, I'll help you. Yeah. You need anything else?
I gotta be good in her class today.
You better.
She seems sick.
She is.
You're gonna scare me today.
Oh,
Dude, you need to shut up. Yes, you should just shut up.
okay, so
That happened the other day.
we got 0.
Zero divided by anything is zero. It doesn't matter what your A is. 2 times A would be, if you put that, 2 times A would be 2 times A of 2, which is -4. But you're being 0. 0 divided by -4 is still 0.
What are we right now?
When we plug the 0 back in, that all that was left was the -3. This 0 squared is 0. -2 times 0 is 0. 0 minus 3.
So we got 0 because that was
Yes.
Look.
Anytime your B is
Oh,
0.
because that's what you got.
Yeah.
Oh.
Alright, Blake's gonna guide us down the list again. What's our axis? -2. Your axis of symmetry on a normal U or upside down U is always the x of your vertex. Always. Alright? Domain on these kind is always all real numbers. On your test, you'll probably see -infinity to infinity. Okay, the range on these, you got to figure out if it's opening up or down. Okay, this one opens up, so we're looking at something that looks like this one in the box. What's the lowest this can go?
You're going to put a bracket, and you're going to put a -1.
Okay, good.
You're going to
Those,
need to put it a positive.
good job. Now let's look at how we knew that. If I go to my vertex, -2, -1, then I know since there's no negative stuck in front of this, it's a positive A, so it's going to open up. So if it keeps going up forever, it's going towards positive infinity. The lowest down it goes is the y of your vertex, -1. Everybody follow that? All right, then Katie's got it on her calculator, so Katie, tell me another point. Yeah, other than the vertex. So anything other than -2.
-1 is 0.
-1. How does that work? Oh, because this is my axis of symmetry. I was looking at that. This is my axis of symmetry. -1, 0 will be right there. So then that's 1 away from axis of symmetry. So I put 1 away on the other side. So you would have 3 points there.
Which one is
0, 3 would be like right here. So then you'd have to put it. That would be 1, 2 away. So you have to go 1, 2 away on the other side. I drew mine whopper jawed.
Yeah, that's whopper gold.
So what was that? 4, 3? Would that be the one that would correspond with it? 1, 2, 3, 4. Yeah, 4, 3. Did you have a 4, 3 on your table?
a -4 is 0?
Yeah, negative. I'm dumb today. Negative. You're right. All right. Everybody okay on that? All right. Let's see what we do on Monday. It says more parabolas in their applications. So applications usually means a word problem. Oh, they start turning sideways on Monday too. We'll have to learn how to do the sideways ones. Bad news is your calculator, I don't know how to do sideways ones in there.
Oh, I'll figure it out.
Where it at?
Well,
Yep.
if you put it in there, wouldn't it
Yeah,
go
watch, I
sideways?
got it, right here.
Well,
You
there's
put the equation in.
the equation that's given to you, x equals. So you've got to solve it for y to get it in there.
Square root of x, dude, goes